We started with an application that had very little isolation. We had a lot of complex dependencies. Everything depended on everything else. We introduced some isolation in the form of libraries that were based around domain concepts, and then we later isolated it even further by giving each of those libraries its own database. That brought us in the transition from monoliths to service-oriented architecture. Now we're going to take the next step and move into microservices. So microservices are a subset of service-oriented architecture. The difference between them is service-oriented architecture doesn't dictate any requirements around deployment. You can deploy service-oriented architectures as a monolith, or you can deploy each of your services independently. If you deploy them independently, that's when you start to build microservices. So microservices require that each of those services are independently deployed. This means that they can be put onto many different machines. You can have any number of copies of individual services depending on your requirements. We still keep all of the rules around service-oriented architecture, maintaining our own data store, ensuring that our services communicate only through a clearly defined API. All of those things still apply. We've just added that extra requirement that we have to deploy the individual services independently. By doing this, it means that microservices are independent and self-governing. If you look at our reservation service and our customer service, certainly our reservation service has a dependency on customers, but our customer service has no dependency on reservations. As a result, we can safely deploy our customer service without giving it any knowledge of any of the other pieces of our application. It probably doesn't need to know about orders, it probably doesn't need to know about reservations, and it certainly doesn't need to know about the menu. It can be completely independent from all of those things. It governs itself in that case. So what are the characteristics of a microservice? Each service is deployed independently. That is one of the key differences compared to a service-oriented architecture. You have multiple independent databases, which it inherits from SOA. Communication is synchronous or asynchronous. So it's not uncommon in a microservice system to see a synchronous communication where you have a request response, you expect the response immediately. But it's also not uncommon to see a more asynchronous approach where you maybe send a request and then you don't wait for a response. Either one never comes, or if it does come, you're not waiting around for it, it'll come in an asynchronous fashion. That's what you're doing when you're building with reactive microservices. All of these things, in addition to other things, provide loose coupling between the components. Because we don't have database dependencies, we don't have synchronous communication dependencies, we don't have even necessarily shared code in some cases. That means that we are creating something where everything is much more loosely coupled. And that can be a benefit, and we'll talk about that shortly. We get rapid deployments. It's not uncommon to see microservices that are deployed certainly less or more frequently than once a week, but sometimes they might be deployed once a day or even multiple times a day. Sometimes that deployment is even continuous, where you check your code in and after some automated suite of tests, it automatically goes to production without any further intervention from yourself. Teams release features when they are ready. We get rid of that big bang style release where everybody has to communicate and make sure all their work is in sync. That goes away, and now teams work on features and release them as they are ready to do so. Teams are often organized around a DevOps approach, so the microservices team will handle the application from developing the code all the way to maintaining it in production. We get rid of this idea of throwing it over the wall to the ops team, which is not uncommon in monolithic approaches, where you'll have the dev team does the development and then the ops team maintains it in production, and those teams may or may not communicate. That goes away in the microservice approach because one team is responsible for everything. So how do you scale a microservice application? Each microservice is scaled independently. You can have as many copies of a microservice as are required. So if, for example, we decide that we need 20 copies of our orders service and only 3 copies of our reservation service, we can do that. That means that the nodes in our cluster, the individual pieces of hardware, will host 0 or more copies of our application. So in this diagram, the cubes represent hardware. And so you can see that in some cases, we actually have 2 copies of reservations deployed on one machine. We have 4 copies of the customer service, but we only have 3 copies of the menu service. So we are free now to make those types of decisions and to deploy our application as required. Technically, these applications don't even have to be deployed in the same data center. We could, in some cases, deploy them in different data centers if necessary. So what are the advantages to this setup? Individual services can be deployed and scaled as needed. Again, you can have 20 copies of the order service and only 3 of the reservation service if that's what's required. You also get increased availability because serious failures are typically isolated to a single service. For example, if our reservation service failed for some reason, we might still get a cascading failure where one instance of the reservation service fails, and when it fails, it redistributes load to the other instances, and then those instances in turn fail because they now can't handle the additional load either. That is still possible with the microservice setup, but when that happens, we've only lost the reservation service. We didn't lose the order service. We didn't lose the customer service. We didn't lose the menu service. As a result, it's entirely possible that a large part of our business can continue to operate. People can still place orders. They can still come and eat in our restaurant. We only have lost the ability to create reservations. We also have isolation and decoupling, which provides more flexibility to evolve within a module. So within any one of these services, you're free to evolve the underlying code as long as you maintain that external API. So as long as you keep the API the same, whatever happens under the hood doesn't matter. If you want to change databases, that's fine. If you want to restructure the database, that's cool too. If you want to completely rewrite the underlying code of the application, no problem. And I can honestly say that I have done all of these things in a microservice architecture. As long as you maintain that API, nobody knows that you've made those changes. And because you don't have to worry about who else might be accessing your database or accessing your code, it becomes very easy to do that. It also supports multiple platforms and languages, so it's very easy to build your applications so that you have some of your microservices written, say, in Java, and then later on, if you want to introduce Scala, you can do that. If you want to have some of them written in C# or Python, that's fine too. There's nothing that restricts us to a particular language. There's also nothing that restricts us to a particular database. So if you want to have part of your application maybe is well suited to a relational database, so you deploy that using a relational database, and maybe another part would be better suited to something like Cassandra, and that's fine. If you want to do that, there's no problem there. Now, microservices do often come with an organizational change. If you're within a large existing organization, this may not be quite the way people are used to building things. One of the things that you'll find is that teams tend to operate more independently. You don't have these big bang style releases. Teams aren't constantly communicating with each other to synchronize on various tasks. They have a particular task, they do that task, they deploy that change, and then they move on. This results in shorter release cycles. So it's not uncommon to see microservices team perform releases multiple times a day even. You might have 5 releases in a day as opposed to having to schedule them at a certain time every week or a certain time every month. This results in less cross-team coordination. You're not, again, constantly going to the other teams and saying, hey, I've got my changes for this feature, they're going in, are you ready for that? You don't have to have that kind of communication. You just release when you're ready. These changes can facilitate an increase in productivity if done right. It can result in teams that are able to release new features, sometimes even within hours of getting information about that feature. You make the changes, you release. If you have a bug that needs to be fixed, you fix the bug, you release. You don't have to coordinate with a bunch of other people in order to get that bug fix out the door. So this can result in an increase in productivity. But it's not free. We talked about the fact that monoliths have advantages and disadvantages, so do microservices. Because you now have many different microservices, possibly written in different languages, being deployed, you may have complex deployment systems and complex monitoring approaches. It's with a Big Bang style monolith release, you just had one process. Granted, it was a large process and it was complicated, but there was only one of them. Now, with microservices, each individual deployment is usually smaller. It's not that big bang, but there's many of them. And so overall, the complexity could actually be larger. It's just hidden across multiple services. You also have multiple monitoring approaches because each of these things may have different monitoring requirements. They use different databases. They may be written in different languages. They may be deployed on different hardware. So the way you monitor them might not be the same. And so that becomes more complex as well. Cross-service refactoring becomes harder. When you were in a monolith and you wanted to do a cross-service refactoring, you just refactored and deployed. That was it. Sometimes the automated tools could do that for you. That's harder to do with a microservice because these things won't be deployed at the same time. And as a result, when you make a change to the API, for example, you have to continue to support the old API. You have to version your API so that anybody who's using that old version can continue to work, and then you can slowly migrate them over to the new version. Once they're migrated over to the new version, well, then you can go back and delete the old version. But that takes time. That's harder than it was in a monolith. And of course, the other thing is that there's an organizational change that comes in here as well. And we talked about this a little bit, but the fact of the matter is large organizations that have been building monoliths for a long period of time have built up structures around that. They may have quality assurance groups that need to test the monolith in a certain way. They may expect deployments to happen on a certain schedule, and they may have various things that are arranged around that schedule. When you start trying to introduce microservices and you want to deploy maybe in a continuous fashion and you want to do a lot of these other interesting things, the organization may not be ready for that. So we have to be very careful when we introduce microservices into an organization that we don't try to do it all at once. Start small, introduce things a little bit at a time, and allow the organization to slowly adapt to the new process before trying to introduce the next thing.